Hey guys, welcome to my channel. This is Defender, and today we're going to be deep dive into NATs and ACLs. For network address translation, we're going to be able to showcase how to hide or essentially translate our private internal IP address of LAN-A subnet, which is 10.0.2.0/24, to our DMZ IP NAT pool, which is going to be from 192.168.1.1 to 192.168.1.252. We're going to be doing this so that we're able to hide our internal IP address once it's passed through our DMZ. Potentially, saying, hypothetically speaking, if we have an attacker sitting here sniffing our connection passing through, and they happen to see the LAN-A's internal IP address, we can actually mitigate that by having them see our internal or translated address, which is 192.168.1.1, right? Even then, we're also going to have ACLs in place on both firewalls for external to actually prevent almost all traffic and only allow traffic that is necessary. So, for example, DNS port on for Cloudflare, DNS server right here on our DMZ, and HTTP and HTTPS for our Apache web server. And for LAN-A, we're going to only allow 192.168.1.1 from that pool to actually pass through the internal firewall. And now the difference between the public facing internet right here, which is my left on Amazon and Google, they're not going to be able to access Cloudflare's HTTP and HTTPS through the browser, right? Sorry about that. And so LAN-A will. So that's the beauty of ACLs. Basically, you're having full control and the packet inspection of what's going in and out of your network. So without further ado, let's start. So we're going to start with R2. Because we're going to create an ACL to allow LAN-A to access the outside of the internal network on R2, and then we're going to configure PAT on the same router, and I'm going to show you guys how to do that. And at the same time, we're going to also verify the translation on this router. So do enable config T. We're going to issue the ACL IP access list 1. We're going to call this 1 permit. Access list 1 permit 10.0.2.0, and we're going to use a wildcard. Okay, now we're going to configure NAT, our pool. So we're going to say IP NAT pool. We're going to call this DMZ with the start address of 192.168.1. with the end of 192.168.1.252 with the net mask of A/24. Now we're going to configure PAT here, which is port address translation. Think of the same thing for IP addresses, but also for port numbers, right? So let's say we have SSH on port 22. It's going to be translated to some random open port, let's say port 2 or port 5. So IP NAT inside source list. Now I'm going to specify 1 because, again, remember we configured an ACL to only allow LAN-A outside of the internal network. So we're going to say IP NAT inside source list 1 with pool, our DMZ pool that we configured right here. And we're going to say overload to have port address translation. Now we're going to specify which interfaces are for IP NAT inside and outside. So our G00 is going to be IP NAT outside. And then interface G01 and 2 is going to be IP NAT inside. So we're going to say interface G01 to 2. Specify range here. IP NAT inside. So do show IP NAT translation. Okay, we'll go to PC2. So again, we have DHCP configured here on all of our PCs, but let's go over here. We're gonna ping google.com. We're gonna give it a minute. Basically what we're trying to see is we're gonna have packets from LAN-B pass over R2 to google.com, right? So once those packets has been successful from PC2 to Google, which we only have one, so I'm gonna send some more. So it's working, but there's no translation that has occurred yet because we only allowed LAN-A to have that happen, right? So if I go to PC6, command prompt, ping google.com. So it's working. We go back to R2 and we see the translations already happening, right? So if we go over here, we see IP config. The IP address of this PC is 10.0.2.13. And the translation is from 10.0.2.13, which again is from LAN-A PC6. And it translates to 192.168.1.1 right here with port 1, 2, 3, 4, 5. It's by increments of 1 as it goes. The protocol is ICMP, which is used to ping. And then this is the destination address right here, right, which is Google's IP address. So that's it for our NAT portion and PAT portion of this simple lab, which is pretty good. And then we're going to do ACLs, right? So we're going to configure access control list to basically filter out traffic going in and out our networks. So we're going to configure and extend the ACL on R2 to prevent hosts in LAN-B from communicating with anything else but the internal network, except, so there's conditions, right? So we're going to permit ICMP from PC1 to PC6 only. So basically we're going to have PC1 ping PC6 only, even though PC1 is able to ping the same other PCs within the same subnet, which is fine. But anything else out of its subnets other than PC6 is going to be unreachable. And then we're going to permit TCP UDP port for DNS traffic from PC1 to Ubuntu, and then we're going to deny everything else. So we'll do that on R2. We're doing that on R2 because it's closest to the source address being LAN-B. So we'll do exit IP access list. Now we're going to do extended. Reason for extended, the difference between extended and standard is, right, if I were to do standard, let's just put, let's do test. We'll call this test. So if I wanted to, let's say, permit traffic, it's only based on IP addresses, right? We can only filter traffic based on IPs and not protocols. With extended, you can filter traffic based on IPs and protocols, right? So for example, let's say any, that's it. Or you can permit a specific IP range or IP address, or you could deny a specific IP range or IP address. Doesn't matter. We're not going to be doing that. So we're going to be doing the extended ACLs, and we're going to call this, you can either number them from 100 to 199, or you can name them anything you want. So we'll just number it 100. We're going to say permit ICMP from PC1, which is host, 10.0.1.PC1's IP address is .11, so we'll say that, to host 10.0.2.PC6 IP address is .13. Okay, so that's good. Now we're going to say permit TCP host 10.0.1.11 to host, which is our Ubuntu IP address 192.168 .3.2, and we're going to specify the port, which DNS by default is on port 53. We'll do the same thing for UDP for DNS, and then we're going to deny everything else. So deny IP any. Now we're going to place this ACL on G02 because again it's closest to our source address. So we'll say interface G02 IP address. Sorry, not IP address. IP access group 100 going inbound. So we'll go back to PC1. Let's see if our ACL is working. Try ping PC2, which will work because again we're within the same subnet. But with PC4 it will not work. Destination host is unreachable. Try with PC5, same thing. Try with PC6. It's working, but can we ping Ubuntu? Host is unreachable. But we are able to use the DNS protocol because we're pinging them by domain name. So PC6, PC5, rather than their IP addresses. So the ACLs are properly configured for part 1. Now we're going to part 2. So we're going to do a little bit more steps here because I left some things on purpose for a reason to explain to you guys why. So we're going to show the running configuration files. So do show run, right? We have pre-configured IP addresses, statically configured IP addresses rather than using a DHCP server for this within our DMZ. And then we have OSPF enabled to basically advertise the subnet on G02 from internal firewall and G01 from external firewall, right? So we're not advertising any of our internal network within the DMZ because even if we had, hypothetically speaking, an attacker sitting here in our network and they happen to breach a specific server or router or whatever the case may be, if they were to have access and they see any IP ranges, they're gonna have questions like, hey, like, what is 10.0.2.0/24? Who does it belong to? And so, you know, you're giving them the idea or basically you're widening your attack surface, right? So what we're going to do is we're going to remove these static routes. So copy, we'll say no, and just basically remove them. Same thing with this IP range. And then we're going to also do the same thing for our Ubuntu server. Okay, let's actually do the same thing on our external firewall before I even configure any ACLs. Do show run, or you could specify, but you know, or you could do the do show IP route command just to keep it simple. But I want to do, so right here we have two statically configured IP routes and another one right here, right? But then we also have one right here, which is fine. This is a static route to the internet. But we do want to remove these three, right? So let's get that going. Because again, now that we have NAT configured, we no longer need these static routes. If anything, we have to configure one static route, and that's the one to the NAT network. So that, and then we'll remove this one. Okay, now we're going to say IP route 192.168.1.0/24 to our next hop being the internal firewall. Now the reason we're doing this is because you know, the external firewall does not know what if they were to receive a packet from 192.168.1.1, they're like, okay, I don't know where this is coming from. So basically, we're turning external firewall. Hey, this network belongs. We have a network that's 192.168.1.0/24. But just to let you know that the next hop for that network is going to be internal firewall. Okay, now we're going to do the same thing on R1. Enable config T, do show run. Okay, we have a lot of statically configured static routes. So we'll remove this. This one's unnecessary. And this one as well. I'm going to say IP route 192.168.1.0, 255.255.255.0, 203.0.11.6, which is the next hop. Do show run. So this is fine. This is the internet. This is going to our DMZ network right here, which is Cloudflare and our Apache web server. Then we have 192.168.1.0, which is going to the NAT address that we configured on the NAT portion of this lab. So now we can start configuring our internal firewall ACLs. So we're going to permit the translated traffic from the internal network to DMZ servers, right? So basically what that means is you remember the pool, which is 192.168.1.1. Basically what we're saying is we only want the NAT address of 192.168.1.1 only to pass through the internal firewall. And then we're going to allow response traffic back to the internal network for established connections. So I'm going to briefly explain what that means very quickly. So first, let's do IP access extended. We're going to call this internal. So let's start with the letter A portion of ACLs. We're going to permit the translated traffic. We're going to permit IP, so all protocols, right? From host or source. The source IP address that we're going to allow is 192.168.1.1 only to any destination, right? And that's because we're just going to go to, for example, let's say PC1 wants to access, say, google.com, Bing, YouTube, Facebook, whatever the case may be, and also our build-detect-defend.net domain here within our DMZ. And if they also want to configure our external DNS server right here in our DMZ through HTTP or HTTPS, right? And that's where I'm going to show right now. So any, and then we're going to allow response traffic back to the internal network for established connections. So basically what that means is, let's say PC1 or PC6 from LAN-A wants to connect to, let's say, Cloudflare, or send some files within FTP or something like that. So basically what we're going to allow is response traffic back, right? So once a computer from LAN-A has established a connection with one of the servers within the DMZ, now the internal firewall, instead of blocking those responses, we're going to say, hey, actually allow the responses back with the computers or the service or services that the allowed source address has established a connection with, being the destination address, right? So that's what we're about to do. We're going to do permit TCP any established connection with any TCP port. And then we're going to deny everything else. Deny IP any. Now we're going to place that ACL in our interface G02. P access group internal N. Okay, that's it for part 2. So let me show you guys a quick thing. So if I go to PC6, right, we'll go to the browser. So the purpose of configuring our external firewall, what I'm going to show you guys is we have, I believe, 4 websites, right? So we have google.com here, and then we have amazon.com here, and then we have build-attack-defend.net here, right? So again, I hope you guys are enjoying this lab. It's a pretty fun, quick, simple lab, very comprehensive as well. So build-attack-defend.net, right? And then we have one more. Now this one is special, right? This one right here is our DNS server within our DMZ, essentially the external DNS server. It's accessed through 1.1.1.1. Now, basically what we want to do is we only want to have LAN-A to be able to access that, that DNS server from those protocol, HTTP or HTTPS. Now, we don't want anyone from the internet to be able to do that as well. We only want anybody from the internet to be able to access our Apache server, which has build-attack-defend.net. But we don't want them to access 1.1.1.1 the same way LAN-A did through the browser. And that's what we're going to do in the external firewall. We're going to block and basically filter as much traffic as necessary as possible to only allow necessary traffic within our DMZ. Basically minimizing the attack surface for our internal network. So we're going to say IP access list extended. Now we're going to call this one external. Again, like this one, we called it internal. So we're going to allow permit ICMP for any source to any destination, right? So we're going to allow traffic ICMP for all. So basically, we're going to have the anybody in the internet be able to ping our DNS server or our Apache web server to see if it's up or running or not. That's all. In a real world case scenario, you can also have DDoS mitigation protection for DNS. I know Cloudflare has that. But yeah, this is a simulated environment on Packet Tracer, so a lot of things are limited here. So now that we have ICMP traffic allowed for all from source and destination, now we're going to only allow DNS traffic to our Cloudflare server only. So we're going to say permit TCP from any source to our host 1.1.1 with port 53. Same thing for UDP. Now, TCP is used as a connection-oriented protocol. It's very reliable, much more slower than UDP, but UDP is more for performance, not as reliable as TCP since it's a connectionless protocol. So we're also going to allow HTTP and HTTPS for Apache only, not for Cloudflare like we did on LAN-A. So we're going to say permit TCP from any source to host 1.1.1.2, port 80, and then port 443. And now we're going to allow response traffic back to the internal network for established connections. So we're going to say permit TCP any establish. Same thing we did for our internal firewall. And then we're going to deny everything else, deny IP any. Now we're going to place those ACLs on our external firewall within our G01 interface. So interface G01. But before I do that, let's actually verify our ACL. I do show IP access list. So ICMP any TCP any host to HTTP right here, and then we have DNS up here, and then establish 4 responses back, and then deny everything else. So everything looks good. IP access external in. Okay, so now let's actually verify if everything is working. So if I were to go back, let's go back to the internet, right here. This is Google, so we're like in the public facing internet. Okay, so I can access myself, I can access Amazon, and I can also access build, attack, defend.net, which is great. Now I want to see, can I access Cloudflare in the DMZ network? Okay, we're gonna see. So we can't access 1.1.1.1, which is great, but can we access it within our LAN-A? Let's actually go to Google and then I'll go back. Okay, let's try. Yes, I can. We go back to our internet. It says request timeout. That's because the public facing internet is not able to access Cloudflare with HTTP and HTTPS protocol. But we can ping it to see if it's up and running, since ICMP is allowed to all. So ping 1.1.1. So we could ping it, but we can't access it through the browser, which is fine. That's what the point of this app was. And if I were to, let's say, actually not have that ACL in place, if I were to put no IP access group external in, and I wanted to actually access 1.1.1, then I would be able to. So if I were to input that real quick, yep. And then if I put the ACL on that interface, let's actually change this. Okay, go back. It's not working. And that's it for this lab. I hope you guys enjoyed something valuable today, and also learned something valuable today, right? So I showed you guys how to configure NAT and port address translation to be able to basically hide the private internal IP address and translate that into a public external one, right? And then we also verify the translation on R2 right here. And then we had 3 ACLs in place. One for LAN-B to filter out very specific traffic, to only ping PC1 to PC6, only allow DNS traffic from PC1 to Ubuntu or DNS server to be able to ping PCs by name, and then deny everything else. So PC2 is not able to access anything within that browser. So we'll verify that right now from LAN-B, any random PC from LAN-B. So if I go to the web browser and input google.com, it won't show up. Nope. If I also did, let's say, build, attack, defend.net, nope, neither 1.1.1. Yep. So yeah, and then for the internal firewall, we also permitted translated traffic from the internal network to the DMZ server with only the NAT address of 192.168.1.1, and then we allow responses back to the internal LAN-A from established connections, right, going outside the internal firewall. And then we denied everything else from that interface. So basically, Apache, so LAN-A is able to ping Apache, but Apache is not able to ping any PCs within LAN-A, because Apache doesn't know the IP range of LAN-A. It doesn't know the internal network mapping at all, right? So if I were to go to, let's say, command prompt, show you guys real quick. ping 10.0.2.13. Let's do 12. Yep, it's not able to do that. But what if I try to ping 192.168.1.1? Still won't happen, right? Because again, we only allowed response traffic back to the allowed source address that we put in place within the ACL. And then we denied everything else from that interface. And then for our external firewall, we only allow specific traffic, for example, like ICMP to both of these servers right here. DNS ports only for Cloudflare, and HTTP and HTTPS only for Apache server. And then we denied everything else. So it was a very comprehensive security lab, but at the same time, not so much advanced, but very, be able to give you guys the idea exactly how firewalls works. And thank you, and I hope you guys enjoy the rest of your day. Peace.